guys, it's Dr. Paige Quinton from the Geology Department at SUNY Potsdam. And today I want to talk to you a little bit about minerals and how we identify them. First question is, what is a mineral? I have an image here of a mineral called quartz. I also have a hand sample of a nice quartz mineral. So a mineral, first thing we need it to be is we need it to be a solid. So this is what we call an inorganic solid, meaning it's not made by life. So we have a solid, and it has to have specific chemical elements, and these are the elements that are on the periodic table. So this quartz mineral has silicon and oxygen as its chemical elements. The last thing we need for a mineral to be a mineral is we need a definite internal organization. And so this is a model of what an internal organization looks like, where I have different chemical elements indicated with the different color balls, organized in a systematic internal crystal lattice. And so to be a mineral, it needs to be solid, it needs to have specific chemical elements, and it needs to have an internal crystal lattice. So, minerals are important for geologists because these are the basic building blocks of all the rocks around us. So if we look at a common rock, for example, this is granite, you can start to see that the different colors represent different crystals of minerals. And so this rock has a couple of different minerals that make it up. For example, the light white to gray minerals that you're starting to see there, are all the mineral quartz. We also have pink minerals there, and those are all a mineral called feldspar. And finally, the black plainy mineral there is a mineral called biotite. So, minerals combine to produce rocks. So the first step as you're starting to study minerals and rocks is to be able to identify different types of minerals. And we do that by looking at the properties of these minerals. And so we can divide mineral properties into a couple of different categories. The first one is its cleavage or fracture. And this is basically how the mineral breaks. And so a mineral can break in what's called a cleavage. And that means that it has some tendency to break along specific planes. A good example of this is a calcite crystal here. And so you can start to see that this looks like a little rhombohedral. That's because it's got rhombohedral cleavage. It's got planes along which it breaks. We can look at this example of biotite here, and you can see that it's starting to break along planes. This has one plane of cleavage. Alternatively, a mineral can break irregularly or jaggedly. That means that there's no preferential plane under which it breaks. It just makes a jagged surface. So, first step is, does it have a preference when you hit it with a hammer? The next thing we can look at is the luster, or how the mineral surface reflects light, whether or not it's pretty. And so we have some specific terms we use to describe the luster of a mineral. For example, this mineral here is an example of pyrite, or fool's gold. And you can see that when I move it around, the light reflects off the surface and has what we call a metallic luster. The quartz we had earlier, if you start to move that around in the light, you can see the light reflecting off the surface very much like a glassy luster. So if it looks like glass, we call that a glassy luster. We can have a dull luster where the light doesn't really reflect all that well. Or we can have, in this case, this mineral here, it has an pearly luster. So we have different names to describe the way that minerals reflect light. You might see the same kind of pattern, for example, glassy, being referred to as things like vitreous. So we have some fancy names to describe these lusters. Okay, the next thing we do is we look at how hard the mineral is, and that is called hardness. And basically this is where we take stuff and we try to scratch the mineral with that stuff to determine how hard it is or how difficult it is to scratch that surface. We're going to come back to this because we have a specific scale that we use to describe hardness. But we'll end with talking about streak and density. First, streak is the color a mineral makes in its powdered form. And this is kind of like hardness in the sense that you're scratching stuff, but in this case, you're using the mineral to scratch something. And so usually what we have is we have something called streak plates. And we have a white streak plate and we have a dark streak plate here. And what we do is we take the mineral that we're interested in figuring out what it is. For example, maybe this one, which has a dull luster, it doesn't have any obvious cleavage, and I'm going to scratch it on the surface of the scratch plate. And when I do that, what I see is that it leaves a red scratch to it. And so this means that that mineral has a red streak. The last thing we look at when we look at minerals is we look at density. In other words, can you lift it? How heavy does it feel? So I can take two minerals and I might see, okay, this one's heavier than I thought it would be. Oh, and this one's lighter than I thought it would be. This one would have a low density, the lighter one, and this one would have a heavy density, or a high density, the heavier one. And so we can very quickly figure out an estimate of relative density. Okay, back to this hardness one, because this one requires a little bit more formal quantification. The Mohs hardness scale is a scale that geologists have created in order to estimate the hardness of a mineral. And so what we've done is we've ranked the hardness 1 to 10, and then we've corresponded that to specific minerals. So talc is a mineral that is very soft, whereas diamonds, the stuff we put in our jewelry, is very hard. And then we have objects, everyday objects that you guys might have around you, that we can use to test these hardnesses. For example, a fingernail. Here, we all have a fingernail, and a fingernail has a hardness of 2.5. So, if I was to take this mineral sample here, and I was to use my fingernail and scratch the surface, what I would see is that this mineral actually, when I scratch it with my fingernail, I leave a mark. And that means that my fingernail is harder than the mineral. If that's the case, that means that this mineral has a hardness of 2 or lower. In fact, this mineral is gypsum, and it has a hardness of 2, and I can scratch it with my fingernail. We have objects like a copper penny. Well, that has a hardness of 3.5, and I can take my penny and try to scratch the surface of a mineral. But note that this copper penny needs to be from 1982 or older. And that's because we changed how our pennies were made. So if you can scratch a mineral with a copper penny, that means that mineral has a hardness of less than 3.5. We have a glass plate. In this case, I have a glass plate, and I can actually take the mineral and see if it'll scratch that surface. In this case, it will not, because this is calcite. And calcite is right there. It only has a hardness of 3. A glass plate has a hardness of 5.5. So, we can use these objects. Last one, a common one, is a steel nail. It needs to be actually steel there. We can use them to test the hardness and figure out the hardness of the mineral and start to figure out what mineral it is because of that. We combine all this information into what is called a mineral identification chart, and that's here. And so what we have on a mineral identification chart is mineral names, highlighted up there, and then corresponding symbols to indicate hardness, luster, the streak, and cleavage. We also have a section where we indicate other weird things about that mineral. For example, I don't have it up here, but magnetite is a mineral that is magnetic. So I can put a magnet to it and it'll attract it. But for example, we have calcite down here. I have an example of calcite here in one variety, and an example of calcite in another variety. They look very different superficially on the surface, but I can do a couple of things to figure out that these are the same mineral. The first is I can do a hardness test. In this case, both of these samples can be scratched with a copper penny. I then look at the luster. In both of these cases, it's either vitreous, which means glassy, that's this one, or it's earthy, which is this one. I can streak it, and I'll get a streak that is white to gray. So if I want to streak this one, I'm going to have to use my streak plate that is dark in color. And the other thing is that if you see cleavage, it will be at 3 cleavage planes at an angle. That means it's rhombohedral. And so you can see this sample here really nicely shows that rhombohedral structure. But you can also start to see that pattern here in this sample. You can start to see the regular planes of cleavage. It's not as nice as that first sample, but you can still see it. The other big thing about calcite that makes it really exciting is that it effervesces vigorously when we put acid on it. And so we have acid bottles constantly with us, and if we drop a drop of hydrochloric acid on it, it will fizz up or bubble up. And that is a good indication that you have calcite. So each mineral has a set of characteristics that make it unique. And your job is to figure out what the characteristics are and therefore what mineral it is. Okay, that is how we start identifying minerals. And I hope you guys had a good time and come back to see me in the future.